Well, sometimes you buy a set of radios, a radio and a power supply, and they probably never live together. Here's this G76. Case is pretty nice, panel is nice. It was a little dusty, but it cleaned up and it worked right away. And here's the power supply that came with it. This wire is old and stiff and dirty, and this thing is considerably dirtier than the radio was. And you start looking in here and look at the dickhead stuff that they've done. They decided that they were going to try to solid state this power supply, and so they took the 5R4 rectifiers, which are perfectly good viable rectifiers, and took those out and did this Joe McGee stuff with aquarium tubing and funny little rectifiers, silicon rectifiers inside the tube, and holy Jesus. Alright, let's do this again. This is the Gonset G76 power supply. It's very conventional. A couple of 5R4s or 5U4s in a full wave bridge circuit, one filter choke, a swinging choke, and two filter caps, 40 microfarad each, 500 volt rating in series with the bleeder resistors on them. This gives you 20 microfarads at 1,000 volts, working volts. Now, why do they do that in a power supply that has an output of 625 volts? The answer is that when there's no load on this power supply, if you test this power supply on the bench, not hooked up to the radio, not transmitting, this B plus floats up to 900 volts or a little bit higher. So if you're replacing these with 450 volt caps like I'm going to do, they better be good ones, because when it's in the receive mode, that B plus is going to go right up to the maximum working voltage of 450 volt caps. If you can get 500 volt or 600 volt caps to somehow do it, because that's why they increase that voltage rating. The receiver power supply, the 265 volt section, is full wave rectifier using 4 silicon diodes and two filter chokes. Again, it's choke input power supply. So there's a choke, 40 microfarad at 450 volts, another choke, another 40 microfarad at 450 volts, and there you go. It's very low ripple on the receiver power supply, but again, with no load on it, this low voltage supply floats up to over 400 volts, and that's why they have a high voltage rating on these capacitors, because when the receiver's connected to it, it drops down to about 265, 300 volts, depending on your line voltage. But with no load on it, no receiver load, radio not connected, it floats way up, and so you have to use these 450 volt rated filter caps. You just have to do it. Don't use 350s, don't use 250s, use 450s. The last little thing in here is they've just they're rectifying some filament voltage, 12 volt filament voltage, with a single diode and a 250 picofarad cap or microfarad cap to give DC for the push-to-talk relays. And in this power supply, there is a relay that's part of the push-to-talk circuit that connects the B plus of the power supply to the radio only in the transmit mode. When you go to receive, the B plus is disconnected inside the power supply from the radio, so the high voltage is not present in the transmitter unless you key it. And the filament winding of the transformer is very straightforward. 12.6 volts, 5 amps with a little pilot light across it on the power supply, just to tell you the power's on. So that's that. Okay, this is the Gonset G76 power supply. 120 volts input, draws about between 3 and 6 amps. And it supplies about 275 volts for the receiver, nominal 650 volts for the high B plus, and the filament voltage. And let's see, my initial testing on this thing, I took my Heathkit Capacitor Checker and checked the leakage on all the filter caps individually, brought them up stepwise in about 50 volt increments, and checked the leakage and let the caps reform. And all the filter caps in the high voltage and low voltage sections worked perfectly with no leakage. The power supply worked fine. No high inrush current, no transformer heating, everything just normal, which is surprising for 1961 power supply, but it was true. But I did see that somebody been in with the golden screwdriver and goofed up a few things, and also the thing was dirty. So I gave it a good cleaning, just like I would do with any old radio, and soap and water and rubbing alcohol, and a little bit of penetrating oil on these transformer laminations to conserve them. They did have a little bit of superficial rust, which is not unusual for an old transformer, but a little bit of tri-flow penetrating oil will conserve those, keep them from rusting, remove a little of the superficial rust, and it's just a good thing to do. So let's turn it over here. I'll show you what I did inside. Nothing magic about this power supply. Now this one has been goofed around with. It's supposed to have two 5R4, 5U4 rectifiers that plug in here, and somebody has put in this diode string, put them in these little plastic tubes, and eliminated the tube rectifiers, and that's bumping the B plus up about 50 volts or so, but so far I've left it, and underload the B plus is pretty close to what it should be. I'll probably put the tubes back in it at some point, but let's see here if I can show you what I've done. A lot of this is house cleaning. But some of it was necessary because somebody been on there and done things that were stupid or ill-advised or sloppy or all three. One of the weirdest things about this power supply was this cord, which I guess is original. I can't tell. I guess it's original. But the outer casing became so brittle with age that you couldn't move the cord. It literally is like crispy critters. It just crinkles. And it was putting so much stress on this plug that the plug was getting broken inside. This plug is actually a wafer. There's this outer face, and then the pins go in, and there's a little holder, a little wafer on the back that holds the pins in place, and that was getting wrenched so badly that it was coming apart. So I wasn't sure if the wires inside were also stiff or what, but I took a utility knife and sliced all but the last inch off of each end off of the thing. And of course the wires are perfectly flexible and in good shape, but the outer covering made it impossible to use. The way most of the time you see these things is with the radio sitting on top of the power supply and the cable bent up, but I wanted to have it, you know, the power supply a few feet away from it, and I couldn't do it. So that was weird. I don't know whether you'll encounter that if you get one of these, but it had to be fixed because it was literally causing the plugs to break. Now here's the line cord that comes in. The line cord's pretty wimpy. This is probably number 16 wire, maybe even number 18. It's pretty small. It only draws about 5 amps or so, so you don't really need a huge wire. But inside, somebody had replaced the original wires with what looks to be about number 22 solid wire. So the hot lead comes over here. They've added a fuse holder inside. This originally had a plug with two fuses in the plug. That's been removed. They put a fuse holder inside, but they used this little tiny wire to carry you know, 5 or 6 amps, and that's nuts. So we took that out and replaced it with some number 16 tin wire. Somebody had added this big heavy wire from to put these two caps in series. This is out of an Arc 5. This is old varnished cloth covered wire from World War II. Somebody put that in there, took that out. This is the low voltage capacitor for the push to talk circuit, and even though it didn't leak, you know, it obviously was blown out here at the end. And also it was mounted like this on this thing, and it would hang down, and when the power supply went in and out of the case, it was chewing up the capacitor. So we just simply put in a nice new modern one. And on this one, even though this filter cap was good, the soldering tab on the bottom came off, and you couldn't really solder to this very well. So I said, the heck with that, and I just put a modern cap in there. I probably should put a modern cap in here to replace the other one. I've got them, but it's working. It ain't broke, so we're going to try it this way for a while. There was some strange contamination in here, and soap and water wouldn't take it off. Electronic cleaner wouldn't take it off. Rubbing alcohol wouldn't take it off. You can barely scratch it with your fingernail. I don't know what it's going to take to get off. Maybe mineral spirits or something, but I'm just going to have to leave it. So anyway, that's what we've done in here. Everything seems to work. I fixed up some solder connections that were poor. Somebody has really done a Joe McGee thing here, and it looks ugly as heck, but it's just the speaker line, and it works okay, so I haven't done anything with it. I thought maybe I would have to build a whole new cable and replace this shielded audio cable, but since I don't have to do that, I'm just gonna leave it. So that's you know, not really what I would usually do. Usually I would shotgun all of the filter caps, and but I haven't done it because they're working okay, not leaking. You know, if there was hum, if there was power supply overheating, if there was high inrush current, if the power transformer went thunk when you turned it on, that's typical of high inrush current. If any of those things were happening, I would shotgun all of the capacitors, but none of it is happening. None of it at all. I think I've got another video where I show the current on the watt meter when you turn it on cold, and it's just perfectly normal. You know, it's somewhere around 50 or 100% higher than the running current, and then it just goes right down to normal. So, you know, big deal. The thing draws somewhere around 90 watts in the receive mode, between 90 and 100, and I think it goes up to, I forget, 150, 200 watts on transmit. When you first turn it on, it goes up to less than 300 watts. You know, for the inrush current, it just goes right back down again, and that's nothing. So there you go. That's the story of this thing and what we've done to it so far. So for sure, I will add a polarized 3-wire line cord to it. But for now, I'll put a polarizing mark on this 2-wire plug. There you go. Okay, we're about to turn on the Gonset G76. Hadn't been fired up for a week. So there's the inrush current. When you want to put the case back on this, put the feet on, set it on its face, and you won't have to struggle with it. And the screws are standard 632 machine screws, 1/2 inch long. Just love the details on this thing. You can see how the edge of this cabinet is dipped down all the way around and fits inside the bezel on the front of the radio. Perfect fit and very strong mechanically and very smooth. So mighty nice stuff. Gonset down in Burbank just made some really nice stuff. Of course, you looked at some of the, well, anyway. Don't chew up your radios, guys. Look at the crap that came out of here. Take a look at your chassis when the cabinet is off it and see what kind of screws it uses. And then go to the hardware store if you haven't done it already. Go to the hardware store and buy yourself some boxes of stainless screws. 632, 832, and probably 1024 or 1032, maybe one of each. And get the matching nuts and just have them. Buy a box at 100, they're cheaper that way, and have them in your shop. And whenever you come across this mix match crap, put in some good stuff. It's just the right thing to do. A lot of engineering went into building these radios. They're good radios. They deserve to have the right hardware in them. And you know, when you buy a box of these, buy 100 of them at a time, 3 cents, 5 cents a piece, 6 cents, 8 cents, whatever it is, it's more than worth it to have the right hardware in the radio, have the radio go back together, and not do what this guy does and stick a sheet metal screw or a wood screw in a hole that's too small and threaded for a regular machine screw. Some radios use self-tapping sheet metal screws. Some don't. Find out what the chassis was designed to use and use it. sure I'm doing this right here. Something's not quite right. It only takes a minute to do this right. Of course, if somebody has jammed a sheet metal screw in a hole that was drilled and tapped and threaded for a machine screw, then it's probably never going to be right again unless you go to the trouble to fix it. But anyway, there we go. And transceiver sits on it like that. And there you've got a complete 90-watt AM station with a VFO, BFO, good receiver, selectable high or low power output. You can go to 10 watts output or 65 watts output. Pretty nice. And it's not very big, and of course if you put the power supply off your workbench, you've just got the unit on the top. Just to make things little safer for the next guy, or so I don't have to remember when I've got so many rigs. I made a note on the outside that there's a 6.5 amp fuse on the inside, which is the main fuse. The fuse holder on the back is for the low B plus line. There's a 3 amp fuse in there. I think that's probably too big. And then I've made a mark on the polarizing mark on the power plug, because it's an old-fashioned plug with the same size prongs, just to make sure that the right prong goes in the hot side of the plug. So that is that's the fuse side inside. So if the fuse blows, you want it to disconnect the hot side from the chassis, and not disconnect the neutral, and have the thing be an ugly surprise for somebody. So that's the deal there. I put a little bit of black tape every 6 inches or so on the power cord, and we'll just let it be there. And you can see that the thing is decently clean now. So this does have a built-in speaker in it. It's got a relay inside that only connects the B plus to the transceiver when you hit the push to talk. So that's a nice feature.